How do we know this is a parabola?
Because y
Well, y is squared with the ellipse too. Only one variable is squared. Very good. And okay, let's keep in mind what the standard form for the equation of a parabola looks like. These are the standard forms, right? Notice, whenever variable is squared, is on what side of the equal sign? Malia, you got to pay special attention here since you missed Tuesday. It's on the left, right? So with parabolas, we know two things already. We know that only one variable is squared, and that variable we want to isolate on the left. Okay? Everything else we want on the right. Correct? When x is squared, it's on the left. When y is squared, it's on the left. Okay? So that's our first step. You keep your goal in mind. Okay? That's the goal right there, and this is our starting point. So these two terms, the y is squared. We want to keep this with the y squared, right? We want whatever variable is squared on the left. Everything else we need to move over to the right. Now, how do you move a positive 8x to the right? Subtract 8x. How do you move a positive 41 to the right? Subtract 41. Can I do things to the left without doing it to the right? No, so I need to also subtract 8x and subtract 41, right? I have done the same thing to both sides. I'm balanced. So, my next line. Now on the left, I have y squared minus 6y. I'm going to leave a blank because what I'm going to do is I'm going to complete the square in my next step. Correct, Leticia? So on the right now, I have negative 8x minus 41. Okay? Now, again, I'm just constantly keeping the goal in mind. Why am I trying to complete the square? Because I want something like that, don't I? Right? I need something like that. We know how to find these. We've been doing it with ellipses, hyperbolas, circles. We use a strategy called completing the square. And how do I find this blank, Alcavia?
You do b divided by 2.
So, and when she says b, what she's talking about is that middle coefficient, right? It's just whatever this middle coefficient is, divide it by 2 and square it. So negative 6 divided by 2 is 3? Negative 3. Y'all are sort of right in noting that it's really not, it doesn't make a difference because 3 squared and negative 3 squared are the same. Okay? You know you're going to square it, so what's negative 3 squared?
9.
Plus 9. Put the plus 9 because it's not just filling in a number. Y'all, this does not look good. Does that look like math to you? 6y 9, it's plus 9. We put a blank there just because to remind us we're adding it. So we need to compensate by adding it to the other side too, correct? All right, now this guy is a trinomial that is a perfect square. What plus or minus what? Y minus 3. When you take that binomial and multiply it by itself, the firsts are going to give you y squared. The outers will give you negative 3y, inners negative 3y, and the lasts, using the FOIL method, give you plus 9. Those combine to be negative 6y. See? These are the same. We have completed the task of getting a perfect square on the left. Now, these combine, correct? What's negative 41 plus 9? Negative 32. Okay, cool. Now, the left is good. Don't we have something like this? Okay, good. Now, we want something like this on the right. Okay? All right, so Malia, you missed Tuesday. So this P is very important for graphing a parabola, okay? It's very important for graphing a parabola. So we want to have 4 times a number times a binomial. Notice this one's not squared, okay? Now, we learned yesterday how to turn this into something that looks like that. The number one realization is we need x plus or minus something in parentheses, right? Okay, so how are we going to get that? What do we do?
You factor
Divide
out
a
the
negative 8 by 4.
You factor
Oh, not yet. We got to factor out the negative 8. Whatever is here, we got to factor it out. And what that does is it puts x, singular 1x in parentheses with another number. Now we're removing a factor of negative 8, meaning we have to divide each term by negative 8. What's that divided by negative 8? X. That divided by negative 8.
4. Positive 4.
Positive 4. It's negative 32 divided by negative 8. So that's positive 4. You can always check to make sure you did it right by distributing back through in your head. What's negative 8 times x?
Negative 8.
Negative 8 times 4?
Negative 32.
Good. So now on the left, we've got this. We're just bringing it down. We're done on the left. But now, okay, we've got our binomial, right? All we need is 4 times p instead of negative 8, right? All we need is a 4 times something instead of negative 8. So this is really what we have. You write that in your margin. Well, I've kind of been, this one's sort of easy to just see, right? It's negative 2, okay? But in your margin, you might want to write, okay, 4p equals negative 8, right? Instead of negative 8, you want to write it as 4 times something. How do you solve this? You divide by 4, and p equals negative 8 divided by 4, negative 2. So, do you just replace this with negative 2? No. You have to write it as 4 times negative 2. You can't change it, right? 4 times negative 2 is the same thing as negative 8. So we're just going to write it like this. And you will see when we graph this that negative 2 is helpful to graphing it, okay? I mean, it sort of looks ridiculous. In math, we've always been taught in the past, like, when you can make it look simpler, do it, right? 4 times negative 2 looks a little more complicated than just negative 8, But the reason we do this is because the p is right there for the reader to see. This just screams to the reader, p is negative 2, and that's important, okay? Cool. How do we feel with this?
Good.
Good. All right. So, now, you'll see, these are the 2 standard forms for the equations of parabolas. Let's just note that, what's the difference between these two? Aaliyah?
The vertical axis is when x is squared.
Right.
And the horizontal axis is when y is squared.
And they're sort of being lazy right here. That axis is called the axis of symmetry. And that really helps you picture it. Because the axis of symmetry cuts a parabola into 2 symmetric parts. Meaning if it's a vertical axis of symmetry, it's like a smiley face parabola, right? Doesn't that make it symmetric? Okay? Or very important is or. With hyperbolas, it's and, right? You have 2 parts. So it's one or the other. Right side up or upside down. Now a horizontal axis of symmetry is going to be a parabola that either opens to the right or a parabola that opens to the left. Okay? Now, hold on. I do want to review the definition. Let's see. Morgan, can you read the definition for parabola?
A parabola is a set of points equidistant from a point called the focus and a line called the directrix.
A parabola is the set of points. What does equidistant mean? Ashley, what does equidistant mean? Just break that word down.
Equal.
Equal.
Distance from the
Good.
focus of the line.
Exactly. All the points that are equal distance to a point that's called a focus and a line that's called the directrix. So, I can give you a point, call it a focus, right? And where do you want to put this line? It's got,
In the middle.
you want me to put it here, 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 or here?
Up.
Right, up, down, or left?
Up.
Okay, up, sure. Here's our directrix, says Morgan, all right? Directrix. Now, there is one parabola that has those 2 features, okay? Can anyone tell me where a point is that is just as close to the line as it is to the focus? What about this one?
No.
No. Which one is it? This one is closer to the. This is closer to the focus. It's closer to the focus, right? We haven't even drawn the vertex yet. I'm just saying. I'm just asking you. Hey, Ashley, is this point closer to the directrix or the focus? This point. It's this far away from the focus. It's this close to the directrix. Okay? Yeah, sure. What about this one? Closer to the directrix. So those points are not on our parabola, correct? The parabola is all points that are equidistant to both. Now, what about this one? That one.
It's equidistant.
It's just as close to the focus as it is to the directrix. That is the most obvious point that's on the parabola, and it's called the vertex. Okay? Right? That point is equidistant to both the line and the focus. Now, you know, there are other ones over here, like for instance, doesn't this one look equidistant? Doesn't it?
No.
Does not?
Not to the directrix.
Wait, hold on. This is the when we're talking about the distance to the directrix, it's like, you know, we're not talking about like the distance to like the middle of it. We're talking about just the closest distance, the perpendicular distance. So do those lines look about right? About equal? Okay, good. So that is on there. The one over here would be, you know, doesn't this look about equidistant to both?
Yes.
Okay, so that's on there. And with those 3 points, you can really paint a pretty good picture. It's just, that wasn't the best. Okay, I mean, you don't have to be an artist, but it's pretty good. Okay, the main points are that, you know, it's upside down. It goes curves away from the directrix towards the focus. All right. Okay. Good. Okay. So, now, I want everyone to stop, think about this to yourself for about 10 seconds. Why don't you talk with someone next to you for another 30 seconds about what you think the deal is here? How would you compare and contrast?
What don't look correct? But you know the X. But the X is
You can use your shape.
All right. Well. All right, raise your hand if you can explain to me a similarity, something they have in common. Jade. They both have a vertical axis, period? Or what's that axis called? Okay. Both of them have a vertical axis of symmetry. Why? Vertical axis of symmetry, and then the reason is because x is square, is the one that's squared. Okay? Let me tell you all a way to remember that if you forget it on a test. In the past, in Math 2, y'all studied parabolas that looked like equations like this. Correct? This. That is a parabola. You knew that before you took my class. And which variable is squared here? X. Now, you all in Math 2 did not learn about sideways parabolas, right? So this must be up or down, right? Okay, so when x is squared, it'll have a vertical axis of symmetry. Very good. Can anyone explain another similarity? Another similarity, Laetitia? Another similarity, yeah.